Hello and welcome to UKIVA Machine Vision Conference 2021. My name is Christian Benderoth and I am the Regional Development Manager with LMI Technologies in Europe. And today we are talking about some typical applications for 3D smart sensors in electric vehicle inspection. First of all, I want to give you a short introduction about LMI Technologies and who we are. LMI is located in Canada with our headquarters in Vancouver. So we are a Canadian company and all our products, all the Gocator sensors are Canadians, so they are all produced in Vancouver. We have our headquarters over there and we run a number of offices. There are 2 more offices in North America. We run 5 offices in Europe, and today we are also run 5 offices in Asia Pacific. Beside our headquarters and our regional offices, we are working with more than 60 distributors and we are placed in more than 40 countries worldwide. LMI Technologies is part of the TKH Group, which is a Netherlands holding, and we also have a number of sister companies that serve machine vision components in the 2D world. Today we want to talk about the electrical vehicle inspection. Especially here in Europe, we see a massive change from the production of cars with traditional power engines and go more and more into hybrid or fully electrical cars. With these changes, we see also the challenges in the quality control and automation during production of cars. As LMI Technologies produces 3D smart laser sensors and snapshot sensors, we can use these sensors in the various stages of the EV battery, but also during the automotive manufacturing process. LMI and our sensor technologies ensures that the assembly tolerances are met and that the maximum cycle life and the safety are achieved. LMI Technologies is the world market leader of 3D smart sensors. And we definitely see a number of advantages to use 3D vision. As each of our sensors has a built-in camera, but also their own light engine, means a laser liner or an LED projector. So we don't use any outside lighting. We don't need to have any special lighting conditions. With these components, the 3D sensors are very contrast immune, and so they are perfect to inspect low contrast objects. We have no issues with any ambient light, as our own built-in light sources are strong enough to give us all the contrast we need. LMI sensors are factory calibrated, means there is no need to do a calibration on site. So the sensors are plug and play, and no calibration tools are needed in the process. The sensors are also calibrated on metric measures. So the sensor delivers volumetric measurements and they provide the shape and the position related parameter. The benefits of 3D vision, especially for the car manufacturing or for the electrical vehicle car manufacturing, is that we see a very flexible automation. In the combination of a 3D smart sensor with a robot, for example, we see the ability for the robot to be quickly and easily retasked on the fly. So you can give the robot new parameters and he will adjust without any time loss. Requires a solution to have the ability to sense, think, and act. Ultimately, adapt to changes in manufacturing, for example, the multi-model production. LMI Technologies develops and builds all their smart sensors by themselves. So we are using 2 different technologies. The one is the traditional laser triangulation. Here we do have a camera and a laser. While the object is moving, we can scan multiple profile lines and create a 3D point cloud. The second technology is the structured light technology. Here we don't need any movement of the part or the laser or the sensor. Here we can take a full 3D snapshot and a full 3D point cloud without any movement on a static object. The Gocator 3D Smart Sensor offers many different applications and options for the battery manufacturing and the battery pre-assembly inspection. The first application I want to show explains the measurement of the electrode width. After an electrode has been pressed and dried, the manufacturer of a lithium-ion cell needs to measure the exact dimensions of the separator and the electrode. The Gocator measurement tools that are on board of the Gocator can be used to locate the edges and measure the exact width. The second picture shows an example where the Gocator onboard tools are used to measure a coated electrode sheet. This is a high-speed application where the Gocator takes up to 10 kHz of measurement speed to measure the profile and make sure that the dimensions are within the tolerance. In the following example, for the battery pre-assembly inspection, we show the tap distance gouging. By using the Gocator onboard tools, we scan and measure the distance of each single tap. These taps can typically be found on the edge of a cell sheet. In order to ensure the quality of the manufacturing process, the Gocator is used to scan and measure the dimensions and make sure that these dimensions are within the given tolerances. After the pre-cell assembly, we now get to the cell assembly inspection. In the battery manufacturing process, the separator and the electrode will be joined together, and the joined cell, including the anode and cathode, is either wound, rolled, or stacked. The stacked cells are then housed into a metal casing and sealed by welding. During the process, the Gocator 3D Smart Sensor can be used to scan the cell sheet and ensure that they are correctly aligned for the stacking. With Gocator, we can also inspect the battery gap and flush inspection. Before the welding will take place, the Gocator can verify the position of each part. The Gocator onboard tools also provide a built-in position detection. This tool leverages the data from all four sides of the battery to extrapolate the correct welding position. One of the assets of Gocator 3D Smart Sensors is the multi-sensor networking. Gocator provides a very simple function that allows to join several Gocator single sensors into a sensor network. A very easy calibration process ensures that all of these sensors are in the same coordinate measurement system. Exactly this feature is used to build a sensor network that scans the battery cell prior to welding. The multi-sensor network delivers a high-speed 3D laser profiling and also a built-in tool that provides the gap and flush between the battery cell and the metal casing. While we now get to the real battery weld inspection. Now we see there on the picture that now multiple battery cells are stacked together and they form a module. Now finally, these modules are combined to form a battery pack. As we want to ensure the correct assembly and the final weld quality, not only the components at module, but also the components at pack level are inspected. And now the Gocator just scans the weld seam for the correct height using a native height detection tool which is based on our blob analyzers. The blob analyzers tool is as well a part of the Gocator firmware that is embedded in each single sensor. The embedded software of each sensor helps to reduce costs, as no external PC or no third-party software is required. Gocator, as an all-in-one 3D smart sensor, can do all these jobs just by using their own firmware on board of the Gocator sensor. The weld inspection requires not only to scan but also identify various defects. We can see typical defects on the weld seam, such as breakages, overflow, offset, cracks, air holes, excessive roughness, discoloration, and any other more. Sometimes we are also facing some challenges like the high-performance scanning of specular surfaces. These seem to be a real issue for 2D and 3D machine vision. Gocator 3D smart sensors, with its customized optics, are able to generate also high-precision 3D data even on very highly specular surfaces like metal weld seams. After we have seen some applications in the pre-assembly inspection and the assembly inspection, we are now getting to the final installation inspection. The place where the battery panels are mounted are typically under the floor panel. In the electrical vehicle, we see a large tray pan sit under the floor panel, and the lithium-ion battery module will be glued to this tray. A dispenser puts a glue bead on the tray. With a Gocator 3D smart sensor that is mounted immediately behind the dispenser, we can scan and inspect the glue bead application for correct dimensions and the surface quality. Another helping tool which can be found in the Gocator embedded software is the surface track tool. This tool can be used to perform a width, height, offset and continually inspection at defined points along the glue bead path and return global measurements and statistics. The inspection during the manufacturing process of battery cells is just one part in the production of an electronic vehicle. In the further process of building a car, we see also traditional measurement applications that can be done by 3D smart sensors, such as the car body gap and flush inspection. In today's car manufacturing assembly lines, we see gap and flush inspection not only on the body or on the car body, but also on a final car on the assembly line. A Gocator sensor is mounted on a robot arm. We can use laser line profile sensors that are commonly used on a conveyor belt where the car is moving, or we see also applications for snapshot sensors that can be used on static application where the car is not moving on the conveyor belt. Doesn't matter which sensor is used, the robot will follow the car and scan multiple positions on the car body. We see typically more than 30 single positions on each side of the car. The special challenge during the process of gap and flush measurement on assembly cars is the gap and flush between the front light and the car body, the flush between the backlight, or high glossy parts that can be found on a car body. Gocator 3D Smart Sensors provide excellent measurement results on all of these different surfaces. Doesn't matter if they are matte or shiny and glossy. Again, the onboard Gocator tools provide a full measurement and give the results to a following PLC, or even provide pass-fail decisions. Another typical application for Gocator 3D Smart Sensors is the automotive weld inspection. The Gocator 3D sensor provides a full 3D scan of the part. The onboard tool identifies the position of the weld seam and measures the dimensions. Failures such as cracks or holes can be identified automatically, and the Gocator will provide a pass-fail decision to the following PLC. In the manufacturing process of a car, also robots that insert parts of the roof or the windshield are required. In order to make sure that the robot will put the part and the component on the exact right position of the car, we are using Gocator 3D Smart Sensors to scan and align the robot. This is a fully automated process where we see a number of Gocator sensors are mounted on the gripper, and while the robot gets close to the car body, the sensor will scan the car body and measure the exact position of the car in order to realign the robot's coordinate system. Gocator smart sensors are fully integrated into the robot world. And so the sensors ensure the correct placement of the windshield or the roof by guiding the robot to the correct position. Many other examples can be found in the manufacturing process of a car. Using Gocator 3D smart sensors also in the combination with robot, doesn't matter if it is an industrial robot or a collaborative robot, gives you a huge variety of different possibilities. Here, for example, we see an application where the Gocator scans the logo position. To make sure that the logo is mounted on the right position and that no capitals are missing, we can use the robot with a Gocator mounted in order to scan and verify the correct logo position and quality. Now we have seen a number of different applications using Gocator smart sensors. Summarizing the advantages of 3D Gocator smart sensors, I want to highlight the all-in-one design of Gocator. The sensor can scan, measure, and control, and that's all on a single device. As mentioned before, though there is no external controller, there is no external PC required. This will definitely minimize your hardware, and it will also lower the costs of ownership. Gocator 3D smart sensors are factory calibrated. You don't need to care about the external lighting, though there is no external lighting required, as Gocator comes with a laser liner or a snapshot LED projector. In all of the before mentioned applications, we have seen the powerful onboard measurement algorithms. There is no need for an external PC or a third-party software. All the functionalities you need to solve your 3D measurement applications are on board of the Gocator. Gocator is a great example of edge computing on a 3D smart sensor. If you are now interested and curious to test your own sensor, there is a way that LMI provides a virtual 3D smart sensor online. Just check our website at lmi3d.com/virtual 3D smart sensor. There you can choose from a variety of application scenarios And then you can use the exact duplicate of the Gocator interface. This all-in-one web browser-based virtual sensor environment will give you the full Gocator experience online. Thank you very much for your 2 days attention at the UKIVA Machine Vision Conference. If you have any further question about LMI Gocator 3D Smart Sensors, please contact us at lmi3d.com. Thank you very much.